welcome to 8.3. This lesson is all of the fun application problems that you can do. I don't know if fun is the right word to use in this setting, but it's some of the different types of application problems that you can use with systems of equations. The text actually has a couple more types of problems than what I have chosen to teach you. We're going to skip some of the rate problems and really focus on the mixture problems and some money problems and things like that. I don't have any set tries. Everything in this lesson says example. Always feel free to pause and try it on your own. There's going to be some repeat patterns to this where I'll do one and the next one is similar in setup, and so you could use that as a try if you wish. All right, so our first type is just translating. And so we looked at this in chapter 1, 5 is less than x, or things like that, twice a number, take away 9, things of that nature. So here we need to have two equations and two unknowns. X and Y are kind of the go-to letters, but no reason that you have to be stuck with those, so choose what you want. It says here the sum of two numbers is 30. So just recall that is our equal sign. So we're just going to write x plus y equals 30. The first number, so let's just say that's x. Let's just assign that value to x. Is twice. When we see twice, we multiply the second number. Well, if the first number is x, the second number has to be y. So you can kind of see that second sentence almost writes itself. So there's our two equations. Think through how you might want to solve those. I don't think graphing is usually the easiest method. Sometimes something lends itself to substitution more than elimination. I think this is a perfect example of that. So we are going to substitute this 2y in for where this x value is here. So over here, my next sentence, when I use that substitution, is going to be 2y, and then continue with the rest of the top equation. Plus y equals 30. And then we're just going to solve. 2y plus y is 3y equals 30. Divide both sides of my equation by 3. And y equals 10. Now I'm not quite done because I always have to have the values for both numbers. Find the numbers plural. But if y is 10, I can plug 10 in right there for that y, and I can solve for x. So x equals 2 times 10, so x equals 20. And that's it. There's another one here, similar, not exact. You might say that it looks even a little bit trickier. We're just going to read through it together. Sum of two numbers is 81. So once again, x plus y is 81. And then instead of calling it the first or the second, this one calls it the larger. Well, just make x the larger. And so therefore y would be the smaller. So the larger is, so x is 12 less than. Remember when we see that expression less than, the 12 goes in the back. So minus 12, twice the smaller, so 2y minus 12. Take this and substitute it in to x in our original top equation here. So the next line will read 2y minus 12 plus y equals 81. Gather my like terms, so 2y plus 1 more y is 3y minus 12 is 81. jump that 12 to the other side, 12, 12, 3y equals 93. Divide by 3 on both sides, and y would be, sorry, 31. 31. All right. So 93 divided by 3 is 31. We're not quite done. We don't have an x value yet. Where do you plug in this y? Honestly, you can plug it in either spot, so don't think you have to plug it into the equation at the bottom. You can put it right there, or you can put it right there. Either of your original equations will work. This one is going to be easier because it's already solved for x. So x equals 2 times 31 minus 12. 2 times 31 is 62 minus 12. So x is 50. Does 50 and 31 add up to 81? It certainly does. So it's true for both equations. All right, so that's kind of the translating. You'll see some of those on the homework, but not too many. The majority of our problems are going to be in this category here, value and mixture problems. You will find, if you go online or you read the textbook, that there are multiple ways to teach this method. A lot of times there's a column or a table of values, some type of chart. If you know how to do that already, my way is just one way. So please feel free that if you already have a method in place that works for you, absolutely 100% use that method. I kind of don't use the chart usually because I think we can boil it down so that it's a little bit more simple than that. So we need two equations. The first equation is always going to be the number of items. How much stuff do you have? The number of items or stuff, whether it's tickets or pounds of peanuts or an acid solution, there's always something in the problem. So literally we're going to have one sentence that just add up the number of items. The second one is going to be either our cost or our mix or something like that. And I have enough examples here that I think you'll get the hang of it, even if the first one seems really confusing. So here we go. In order to make necklaces on Etsy, Jane purchased 80 beads. This is the total number of beads she purchased. That is the number of items. What kind of beads is she buying? She's buying silver that cost 40 cents and ones with gems that cost 65 cents. So over here off to the side, I am going to assign, you can use S and G if you'd like. I always just like X and Y. So X is going to be the silver ones. And Y is going to be the gems. And we're going to have one cost equation and one physical number of items. So there are 80 beads. Some of them are silver, some of them are gems, and they add up to 80. The silver beads cost 40 cents. So every X cost 40 cents. So I'm going to multiply those two things. The gemstones cost 65 cents. So plus 65y. And the total money is $39. All right. So there's our two equations. That's really the hardest part. The solving it, we've already practiced in 8.2. So now it's just a matter of solving. Usually, if it's money related, I will go through and multiply my money equation by 100, and that's going to clear out that decimal. So this is going to go to 40x plus 65y equals, don't forget to multiply that 100 times the 39, 3900. All right. So these are my two, I'd use my highlighter, but then I can't erase it. These are my two equations, the one here and the one here. I'm just going to use a simple elimination. If this is a positive 40, I can multiply everyone here by negative 40, and that's going to allow me to eliminate my x's. So minus 40x, so that goes to there, minus 40y equals minus 3,200. And you don't have to write that on top. You can write that underneath if you wish. I'm just trying to conserve space here because with my slate, I write really large. All right, let's add straight down. This is going to drop out. We have a negative 40 and a positive 40. So, and then the y's, negative 40y and a plus 65y, we have 25y equals 700. If I divide both sides of that equation by 25, 25 divides into 700 28 times. You can put the 28 here, or you can put the 28 there. Ask yourself what is more simple looking. I definitely think this equation here on the top is more simple because they just have to add to 80. So if you have 28 of y, then how many x's do we have? Well, let's plug it in. It's just a matter of subtracting, really. So just subtract 28. X has to be 52, which means there are 52 silver beads and 28 gemstone beads, because that's how I assigned my variables. That's it. We're going to do that many more times. I don't remember how many. Okay. So a business store charges 49 cents for color, 9 cents black and white. His total bill was $12.90, and there are 90 copies total. So let's make X equal to the color copies, how many of each type, and then Y will be how many black and white copies we end up with. We need one equation with the number of total items. Our total is 90. So X plus Y equals 90. We need one equation tacking on the money. Every color copy costs 49 cents, 0.49x. Every black and white cost 9 cents. And there was a total of $12.90 spent. Once again, if you multiply through by 100, it's just going to have the effect of clearing out that decimal. And so now I even have a cleaner workspace because I could just scribble out that decimal from multiplying through by 100. All right, what's the easiest way to solve this? Well, you can either multiply the top through by negative 49 or the top through by minus 9, whatever you wish to do. I multiplied through by minus 9 just because it's a little smaller. So this time I'm going to eliminate the y. And that is going to give me, and I'm going to write it right underneath. So negative 9x minus 9y equals minus 810. Draw my line. Add my column straight down. 49x, take away 9x is 40x. My 9's drop out. 1290, take away 810 is 480. Divide both sides of my equation by 40, and x equals 12. Sorry, I was looking at my y answer there. Oh, sorry. Y equals 12. When I did this in advance, I actually wrote the wrong variable down here. Oh, I'm doing it here. Here we go. You guys are probably like, McNutt, get it together. I wrote y, I meant x. There we go. So x is 12. Thank you for your patience on that. All right, let's put in the 12 right here because it's the easier of the two equations. And so 12 plus y equals 90. Subtract the 12, subtract the 12. Y equals 78. So that means that there were 12 color copies and 78 black and white copies. You can even like substitute in for the second one and make sure that what we're saying is true. You can even double check, does 49 times 12 plus 78 times 9, does that add up to 1290? And you can plug that back into your calculator and you have an instant check to make sure that you've done it correctly, because it has to be true for both equations. All right, here's another one, similar, not exact. It has to do with the community college credits. I remember I chose one of these off the homework, so I would imagine that this is super similar to that. So each class, McNutt Community College, I named it after myself, is either 3 credits or 4 credits. The member of the golf team are taking a total of 27 courses. A total of 27 courses. There's our stuff total. So let's make X equal the 3 credit classes. And let's make Y the 4 credit classes. And we know they add up to 27. So X plus Y equals 27. We know they take a total of 89 credits. Every X is worth 3 credits. So instead of money here, we're talking about credits. Every Y is worth 4 credits. And it's a total of 89 credits. No decimals here, which is kind of nice to not have to deal with that. Let's multiply everybody in the top equation through by -3. So when I write it right here, I get negative 3x minus 3y equals minus 81. Draw my line, add my columns, the x's drop out. 4y subtract 3y is 1y must be 8. If x plus y is 27, and I know that that y value is 8, if I just subtract those, I should get that x is 19. So there are 19 3-credit courses and 8 4-credit courses. All right, so far so good. We've been through so many. I hope you're still with me. If you need me to help you work out any of the homework problems related to this, shoot me a screenshot and text it to me, and I'm happy to work it out, send it back, things like that. All right, this one is one of the ones that's just a little bit different. This is a mixture problem. Notice that it doesn't tell us a total amount we spent. It tells us how much we want the mixture per pound. So let me start at the top. Pistachio kernels sell for $12 per pound and almonds for $10. How much of each type should be used to make a 50-pound mixture? Here's our total amount of stuff that sells for $10.80 per pound. So if we had 50 pounds at $12.80 per, $10.80 per pound, how much money would we spend? What would be that equivalent to, Hold on, I lost my little guy. There he is. What would be my equivalent? All right, as you can see, I can't go back here for some reason. To the total, like the one that said 1290 for the color and black and white copies. What would be that dollar amount total? So I am going to multiply those two numbers, and I'm going to get that the total would be $540. This would be the total amount of money we would spend. And now it literally is exactly the same. One equation with the number of items. So let's make X the pistachios. And let's make Y the almonds. So I have 50 pounds. X plus Y is 50. And now I just have the money. 12X, pistachios are 12 per pound, plus 10Y is a total of $540. Because it didn't tell us the total amount we'd spend, it told us the total that we wanted the mixture to be per pound. So this was the extra step that we had to do. I just want to say that one more time. Okay, so now you have your equations. It should be getting, the pattern should be there. Let's multiply the top equation through by something. 10 is always an easier number to multiply through by. So let's multiply by negative 10 everywhere. So that's going to give us negative 10x minus 10y equals minus 500. 12x minus 10x is 2x. The y's drop out. 540 take away 500 is 40. Divide by 2, divide by 2, so x is 20. If it has to add up to 50, 20 plus what adds up to 50? The y has to be 30. So we have 20 pounds of pistachios. And we have 30 pounds of almonds. Oops. Plug, like kind of substituting back what those variables are standing for. Here's another one. This one has to do with ticket sales at an amusement park. The numbers are kind of nasty. I'm not going to lie. With a calculator and some technology, you'll be able to get through it. So I just wanted to throw one example on there where it wasn't beautiful numbers like 12 and 10 and things like that. So some tickets are adults, some tickets are students. So let's make X the adults, or juniors in this case, and Y is the junior admissions. And it says that it's $32.95 for an adult, $22.95 for a junior. On a single day, the park collected, this is that total dollar amount we're going to use, and a total of 360 people. So we're going to go X plus Y equals 360. That's our stuff equation. Then we're going to tack on the money. So $32.95 times every adult person, plus for every junior, they made $22.95. And they sold a total of 10,612 tickets. All right, I am going to multiply this through by 100 to clear the, actually I didn't. When I solved this one out, I said, let me do one example where I don't clear the decimal, because if I add 2 zeros right here, this number gets pretty big. So I said, let's just keep the decimal in this one. You get to choose. You've seen me do these enough now where you can kind of choose that. So I am going to multiply everybody in the top by a negative 32.95. That sounds really gross. All right. So minus 3295x minus 3295y equals this times this. Go to your calculator. It is negative 11,862. Draw your line and add your columns. Your x's are going to drop out. You have a positive 2295 and a negative 3295. So this actually subtracts to a pretty nice number. It's just negative 10y equals 10,612 minus 11,862 turns into minus 1250. And when we divide both sides of this equation by negative 10, we get 125. So at the end, it all works out. Now, x and y in this case stand for the number of people. So just keep in mind, and all of this, for many of these, this is true. If you get a negative or a decimal for your final value for one of the variables, you've probably done something incorrectly, because how do you have a negative person? Or how do you have like 0.2 of a person? So they have to work out in the end to be nice. All right, x plus y equals 360. We know the y is 125. So subtract it over, and there must be 235 adults. So then just take a moment, go back and look at your variables. X is the adults, so 235 adults and 125 juniors. Here's another mixture one. This is similar to the pistachio one. So we do have to kind of figure out a total. Amy's experiment required her to mix a 50% acid with an 80% acid to create 200 milliliters of a 68% acid solution. How much of each type should she add? Well, let's make X a 50%. Let's make Y the 80%. How many milliliters? That's a volume, so that's our stuff, that's our number of items. So we're going to mix these two things, and it has to add up to 200 milliliters. The X is a 50% solution. The Y is an 80% solution. And the total 200, the 200 milliliters needs to be at a 68% solution. So this is probably the hardest piece of the whole thing, because you have to remember to multiply those two numbers together. And so we're going to get 136. Multiplying these two together. All right. You can keep the decimal, you can ditch the decimal, and then multiply through by 100. So if I multiply that by 100, it gets rid of that. If I multiply that by 100, it gets rid of that. And that will add 2 zeros to my end here, multiplying the back by 100. Let's multiply this by negative 50. And rewrite it so that my x's drop out. So minus 50x minus 50y equals minus 10,000. Draw my line. My x's drop out. 80y minus 50y is 30y. 13,600 minus 10,000 is 3,600. When I divide both sides of my equation by 30, I get 120. And so there's going to be 120 milliliters of the 80% solution. And if they have to add up to 200, then the X must be 80. And so there must be 80 milliliters of the 50% solution. Final answer. All right. I think there is just one more here. There's one interest question on the homework. So if you want to add that this is interest up on top here, it's still in the mixture category. I would put them all in the same category. Hopefully you see the pattern that I am doing. All right, the one thing we do need off to the side here, let's do a little crash course about simple interest. Simple interest is the equation principal times rate times time. We're talking about a 1-year situation here, so the time is equal to 1. So the interest is equal to just the principal times the rate, because the time is going to drop out because it's just 1 year. So Isaac has 2 different student loans. Maybe some of you can relate. I have loans for my child in college. One of the loans was at 3.2% simple interest and the other at 4.5%. I have an extra R there. After 1 year, Isaac owed $442 in interest. So how many dollars of loans do we have? What is our total amount of loans? $12,000. So some of our money is at a 3.2% interest. So this is the amount of money that we have at 3.2, and the Y is the amount of money. Let me do a better job of writing it all out. The amount of money at 4.5%. And we know that these 2 loans have to add up to $12,000. So there you go. Our loans have to add up to $12,000. Some of our loans is at 3.2%. Now, 3.2%, don't forget to move the decimal twice. So that's going to be 0.032. Moving it twice, you have to put in that 0 as a placeholder. So 0.032x is going to represent the interest, the principal times the rate, plus the amount of money that's at 4.5% is going to be 0.045y. And then we don't have to multiply here because it tells us the total interest. So this represents the interest from the first loan. This represents the interest from the second loan. And that total interest is $442.50. All right. This one is just a little tricky because I have a 3-digit decimal here. So in order to do this without decimals, multiplying through by 100 isn't going to work. You actually have to multiply through here by 1,000 to move that decimal 3 times. So first thing I'm going to do is I'm going to ditch that decimal. So I have 32x plus 45y. Multiplying this back number through by 1,000, it's going to move that decimal once, twice, 3 times. I'm going to have an extra 0 right there. So equals 442,500. I know it's a big number. We're just going to deal with it. It's going to drop out soon. All right. I'm going to take that top equation and multiply it by a negative 32. And I'm going to write it right under here. So this equation is going to go right here. Minus 32x minus 32y equals multiplying 12,000 by a negative 32 gives me negative 384,000. Check it on your calculator. Draw my line. The x's drop out. 45 subtract 32 is just 13y. When I subtract these two big numbers, I get 58,500. Divide both sides by 13, and it turns out that y is 4,500. Now, my loans added up to 12 grand. So we're talking bigger numbers here in general. My student loans added up to $12,000. So if one of them is 4,500, just subtract these two numbers to discover that x must be 7,500. So I have $7,500 in loans at 3.2%. I have $4,500 in loans at I'm sorry, I probably should have written it as an at 4.5%. All right. So that's it. I hope that you kind of saw the pattern through there. The mixture ones are just a little bit trickier. The interest one is just a little bit trickier. Reach out on the homework, and I hope you find success. Thanks for watching. Bye-bye.